This is my video tutorial for the notes on systems of equations by substitution. It's chapter 4.2 in your textbook. When you're taking notes on this, please take notes on everything on this frame and then two of the five examples I'm going to be going over afterwards. So, to solve a system of equations by substitution, you're going to be getting a coordinate where the two lines would meet. If you're doing it graphically, it would be you're creating a graph, an x and y axis, and graphing it. But if you don't have graph paper, you can do it algebraically, as we're about to do. First, you must isolate one variable. We'll go over an example together. Example is x plus 2y equals 6 and x minus y equals 3. So what would be a solution, an x and a y, that would satisfy both of these equations? First, I'm going to want to get a variable by itself, and I'll move the y over to the right-hand side by adding y to both sides. Keeps everything positive. And now I have x all by itself. That was my first step. One of the variables all by itself. Second, substitute what that variable equals into the other equation. So I want to take y plus 3 and substitute it in for x in my other equation. So I end up with y plus 3 instead of x plus 2y equals 6. Then I'm going to solve the one variable equation. Y plus 3 plus 2y equals 6. I can combine like terms. Get 3y plus 3 equals 6. Then subtract 3 from both sides. I end up with 3y equals 3. Divide both sides by 3. I get y equals 1. So I've solved the one variable equation. Now, the last thing I'm going to be doing, I can substitute 1 in for y. That's part of my solution. I got the y variable done. Now, last step is to plug in the solve variable into one of the original equations. I could plug 1 in for y here or 1 in for y here. It doesn't matter. Either x plus 2 times 1 equals 6, or we can also say x minus 1 equals 3. If I solve either one of these equations, I end up with x equals 4, and that becomes my solution. 4, 1. This would be the solution, and 4, 1 would work for either one of these equations. Makes them true. So we're going to go over some examples now. Please take down 2 of these 5 examples. The first one, you can see that I'm trying to get an x, y that works for both of these equations. And if I don't have graph paper, I got rid of all my graphing on here. I can do it algebraically by first isolating one variable. So it turns out if y is all by itself, it's isolated. Check. And then second was to substitute what that variable equals into the other equation. So x plus 3, I'm going to substitute in for y in my other equation. I have x plus 3 equals 5x minus 5. And then solve the one variable equation. So this is a one variable equation. I can solve for x. Get x to one side by subtracting x from both sides. Then get all my constants to the other side. I get 8 equals 4x, or x equals 2. And so I can put that in for my x. in my solution. And now I'm part of the way through it. And next thing I need to do is plug in the solved variable into one of the original equations. So if x equals 2 here or x equals 2 here, what is y going to equal? And either y equals 2 plus 3, or 5 times 2 is 10. 10 minus 5 gives me 5. So either way I get or y equals 5. And that is so I have these little sub answers here, but my solution is right here, 2 comma 5. That's the coordinate at which both of these lines would intersect. My next one, x equals 2y minus 8, and x plus 2y equals negative 12. Finding that coordinate, x comma y, that fits both of them, I must isolate one variable, which has already been done for me. I have x by itself. Second, I'm going to substitute what that variable equals into the other equation. So x equals 2y minus 8, so I'm going to put that in for x in my other equation. And then solve the one variable equation for y. I have combining like terms first, and then start solving. So I use my inverse operations, add 8 to both sides, and then divide by 4 to get y equals negative 1. Oh, that should be negative. There we go. So last step is to plug the solved variable into one of the original equations. So if x or y equals negative 1, I need to solve for x. So I can plug it into either equation, y as 1, and solve for x. In both cases, I'll end up with the same answer. You can choose the easier of the two. And in this case, I would get x equals negative 10. And that becomes my coordinate at which both of these lines would meet, negative 10 comma negative 1. All right, my next example is going to be x minus 2y plus 11 equals x equals negative 2y plus 11, and 3x plus 3y equals 30. Now, I'm trying to find that coordinate, and I'm first going to isolate the variable. It's already done for me. This one, I'm substituting in that variable in for that for x. So negative 2y plus 11 has to be put in for x. And you have to multiply, so you have to put this as parentheses because that's the total value of x is right here. And it's being multiplied by 3. So I'm going to use my distributive property first to multiply to the negative 2y and the positive 11. Then I'm going to combine like terms, use my inverse operation, subtract 33 from both sides. I end up with y equals 1. So if y equals 1, I can plug that into either one of these equations to solve for x, because the last step is to plug the solved variable into one of the original equations. Either x equals negative 2 times 1 plus 11, or 3 times x plus 3 times 1 equals 30. So in both cases, I'm going to end up with x equals 9. And that becomes my solution, is 9 comma 1. Next example is y equals 2x minus 4. And the second equation is 7x minus 2y equals 5. So I put this x comma y there just to remind myself that I'm solving for this coordinate. First going to isolate my one variable. Already done, I have y by itself. Second, I'm going to substitute that 2x minus 4 in for y. And then solve the one variable equation. So all I have is x in here. And I need to multiply that negative 2 into each term in here. So it's minus 2. I know it's minus 2, but I can treat that as a negative 2, and I'm going to multiply that to each term in there. I end up with negative 2 times 2x gives me negative 4x. Negative 2 times negative 4 gives me positive 8. Combine like terms. Then I'm solving the equation by subtracting 8 to both sides and dividing by 3. So I get x equals negative 1. And plug that in for x. So plug that value in for x. And now I'm doing my last step, which is to plug in the solved variable into one of these equations. So if x equals negative 1, either 2 times negative 1 minus 4 equals y, or 7 times negative 1 minus 2y equals 5. And in both these cases, y equals negative 6. And that becomes my solution, negative 1 comma negative 6. And my last example is y equals 2x plus 3 and y equals 5x. So my first task is already done for me because y is by itself. These are both in slope-intercept form. And my second step is to substitute. So I could put 2x plus 3 in for y, or I can put 5x in for y over here. And either way, it becomes the same equation. I'm going to be solving for the x variable. I get 3x equals 3 and x equals 1. So I'm going to replace my solution here. The x term is going to be 1. And last step is to plug in the solved variable into one of the equations. So if x equals 1, either y equals 2 times 1 plus 3, or y equals 5 times 1, and y equals 5. Please let me know what you think. I hope you have a good day, and I'll see you soon.